And welcome everybody to this week's exciting episode.
These are not the droids you're looking for.
Okay.
10 points for you.
What?
If you can tell me which character said that in Star Wars.
Obi-Wan Kenobi.
Yes, 10 points. 10 Josh points to Pirate. And Pirate only. No one else. Just 10 points for you. You will eventually be able to trade them in for our own merch.
Excellent. When I've built up quite a few, hey.
Yeah, well, when you get to 1,000 again.
So this is where Josh intros are going now. Is it just Star Wars quotes?
No, it was the only thing that came to mind. Again, I'm still struggling for intros. I'm not going to lie. I've reached fatigue, and I am scraping the barrel.
You need an intro machine, something to come up with them for you.
I do. Well, you've just reminded me. I thought about using AI for intros. But I have to admit, I'm kind of getting put off by AI with how much it's being shoved into my face.
Yeah.
You know?
Yeah,
and
it is everywhere now.
I was so happy when I saw that social media was going to make an announcement. Well, they did make an announcement about they're going to change the settings in the next few months at some point next year in 2026 where you can turn AI off.
All right.
So as soon as that comes out, I will be doing that because everything on my feed now is
on what?
Mainly Instagram Reels and TikToks.
Okay.
You know how it is. You know,
So AI created videos.
Yeah, it's all the time, bro.
Yeah.
And it's like you work a busy day, and I don't know if everyone's the same. It might be TMI, but there's a certain moment every day where we have to relieve our bowels is the nicest way of putting it. And that is the prime 10-15 minutes where you're just scrolling. You're kind of just
doom scrolling.
Yeah. You know, and I would say 80% of what I'm scrolling, and to the point where I'm switching. So I'll be on Instagram Reels for a while, and I go, oh, AI. Oh, puppy. AI. Oh, new recipe for food. Oh, AI. And then I'll switch because I'm getting fed up with the AI. And then TikTok's exactly the same, where it's just AI. So, yeah, I can't wait for that setting to come in so I can switch it. Because it's not about getting tricked. You know, believe me, I have been tricked a few times where I think, oh, this is real. Like, the one that got me instantly, where I couldn't believe I fell for it, was I showed my wife this video of this new animal that was discovered in the burrows of Japan, and it was like this little chipmunk, fox thing.
Yeah.
And it was like, oh, this is the Arctic chip fox or whatever it is, and I was like, oh, this is pretty cool. And as soon as I showed it to her, she was like, that's AI, and I was like, yeah, it is. Yeah. How did I not know that was AI? And then ever since that moment, I've kind of had a chip on my shoulder, a chip fox on my shoulder about AI. And it just keeps tricking me, and I don't like it. And then it's also making me having to do more research and Google things because it's coming up, and I'm like, that doesn't seem real. I'll Google it, and it's not real. And I'm like, this is annoying me now.
And then the first thing that happens when you Google stuff now is an AI-generated explanation.
Yeah, I've switched that off. Yeah, there's a little bit at the top where it's like, do you want AI involved, or it's like just the web? So I click it on just the web, so I don't get that rubbish. I just get the top results for it. And then come to my own conclusions without AI. But it's weird, isn't it? Because it's one of those things where AI can be very, very useful for things.
It can be a helpful tool.
But I'm also very worried about it. I know we've had this conversation before. Yeah. So, but yeah, that's my little rant for today.
Okay.
I'm starting to feel slightly more negative towards AI than positive. So, but that's just me.
Josh rant over.
Yeah, that's my rant for today. Let's give it we didn't do any sound bites this week, pretty much. So, what do you fancy?
Yeehaw.
There we go.
And with that, let's
Yes. Episode starts at 5 minutes and 4 seconds.
okay. Well,
What have you got for me today, Pirate?
this one's a bit of a mystery one, really.
Oh, I like a mystery.
I've written at the top what I'm calling the research is the Big Bang Theory wrong?
Oh, watching copious amounts of those shows, those episodes, yeah, it is wrong to like the big. Oh, are you talking about the actual Big Bang?
No,
Yeah.
This is a sciencey one.
Oh, yeah. We haven't had a sciencey one for a while.
Prepare for that, people.
My brain is going to be melted, as is the thousands of people that download the podcast. But, in your defence...
Hopefully I'll explain it.
You do have a few people that actually really love the sciencey ones.
Yeah.
And then the majority of people are like me, where they're like, I liked it, but I'm still confused.
Right.
Yes.
I'll try and not confuse you and make it just so you like it.
Yes. Okay. So is the Big Bang Theory wrong?
Well, let's start at the start. How did we actually come up with the Big Bang Theory? Because it wasn't that long ago, really, only a few hundred years ago, people looked out into the night sky and, well, for one thing, they thought the Earth was the centre of the universe and the sun revolved around the Earth. We now know that it doesn't. And, they just assumed that every star in the night sky were just stars. We didn't really know what they were or how far they were away. But that was the entire universe.
Yeah.
And then this guy who had a very famous telescope named after him came along.
James Hubble.
Hubble, yeah.
Is
I
it
think his
Jim?
first name was Edwin.
Half a point.
I think, yeah. And he came along and he realised that actually the stars in the sky are part of our galaxy and there are other galaxies out there.
Which is wild in itself.
He was the guy that figured it out.
That's pretty cool.
Yeah. Yeah, it's it's already quite a big tick on your...
Yeah, that guy deserves a telescope named after him.
Exactly. But not only that, he realised that out of all of the galaxies that you could see out there, they were all moving away from each other. When he measured the distance between them, they were all moving apart. And the further away he was looking for galaxies, the faster they were travelling. So he kind of came up with the idea of the expansion of the universe. And he called it the Hubble constant. Yeah?
Okay.
And he measured it to be, the universe itself, the whole universe, everywhere, is expanding at 67 kilometers per second per megaparsec. A megaparsec is about 3,500 light years.
I'm glad you said that because a megaparsec to me sounds like a really nice pie. I don't know why.
Does it?
Yeah, I don't know why. Like I'm serving up megaparsec with chips.
I'd say a megaparsec would being like 1,000 parsecs is just definitely a few Kessel runs.
For sure. That is a crazy amount though. 67 kilometers per second.
Yeah.
That's wild.
For every 3,500 light years of space
That's quite crazy.
Yeah, and there's a lot of space out there,
Yeah.
I mean, our galaxy is 100,000 light years across, which is about, 30 megaparsecs?
Or 64 Kessel runs.
Yeah,
okay.
I mean,
that's odd.
That's what I mean. He figured out space is big. It's really, really, really mind-bogglingly big, and it's expanding at a ridiculous rate everywhere.
Yeah.
Yeah? Which is kind of... Then they sort of turned the timeline around and went, well, if it's expanding now and it's this big, surely if you went back in time far enough, there'd be a point where everything was really close together.
Also a good point.
It's a good theory, yeah?
Yeah, okay, so there would have to be a starting point where there was one thing that would then expand.
Yes.
Okay, yeah, I'm picking up what you're putting down.
Now, I'm sure you'll have seen a diagram of this several times in your life. It's called the Lambda CMD model, and it looks like a condom, Do you know what I mean?
Right, fair enough.
So the Big Bang is the knobble on the end of the condom, right? That's the universe being created, and then what happened was the Great Expansion, which which makes up the body of the condom, and then as you go
Right.
down the length of the condom, that's your timeline.
Okay.
You know, and it's still expanding now. So it's a weird looking condom because it's quite wide at one end.
Yeah, not the ones I'm buying, mate.
No. But that's what the diagram
Yeah,
of the
I'm with
universe looks like. You know what I mean?
Yeah, it
So
makes sense.
at the tip of the condom, the universe is just soup. It's just a soup of hydrogen, helium, until that then formed into early stars. The early stars exploded, created more elements, heavier elements, and more stars were made. Galaxies formed. You know, billions and billions of years passed, and now we are in the universe as it looks today.
Yeah. It reminds me of like, I don't know how true it is. I don't know if I've mentioned before. I saw a video of like someone had an apple, and they said that if you put that in a box, completely seal it where nothing can get in or out,
Yeah.
after millions of years, everything that can happen scientifically can happen inside that box.
Philosophically, yes.
Yeah. Oh, but not, it can't actually happen. So it kind of reminded me of that, where it's like when you said, was it hydrogen and
helium. Yeah.
is what kind of created everything that we have today. Yeah. Okay. I'm with you.
Okay.
Is that the case?
And well, this is the thing. The clever boffins obviously decided on this theory, and a lot of very clever people agreed with each other on it. Einstein, in fact, wasn't actually that keen on the Big Bang theory.
Oh, I have heard
Just
this.
as a side note.
Didn't he? Was it him that thought that the universe had always been there, or it's?
I'm not sure what his take on it was. I think he pretty much thought it was infinite. Yeah.
Yeah. There's so many theories that follow this, though. We're probably going to end up going into
this.
it.
This is the thing. Science exists as just a whole group of theories, a string of theories that, you know, if we prove them to be correct, they become rules, and sometimes theories remain theories, even though we think that they're absolutely perfect and you know, govern the laws of everything. But then we start finding out that we're wrong about that because of leaps and bounds in technology, AI, you know, stuff like that. Well, not that AI is involved in this one, but the better telescopes we started using, the further we could see. And we started seeing mismatches between what we know as theory and what we were observing. Seeing things that kind of started defying explanation. But again, is it because we just don't know what we don't know? Now, if you go back 200 years ago, we didn't know about the planet Neptune, but we knew about Uranus, however you want to pronounce it. Yay. We knew about Uranus, and we could see its orbital pattern, but its orbital pattern seemed off. It didn't calculate correctly. And then someone realised that actually, if it was being interfered with by another planet further out that we couldn't see, that would explain it. So they did the maths, and Neptune was the first planet ever discovered entirely by calculations.
Oh.
Yeah.
Do we have pictures and stuff of Neptune now? Oh, but this is like hundreds of years ago.
This is time ago.
Okay. A fun fact.
Yeah.
Neptune is slowly becoming my favourite planet.
Neptune.
Yeah. It's always been Saturn because it's got the ring, which is kind of cool. But as time has gone on, there's just something about Neptune that rips, dude.
Okay, fair enough. It's a frightening place.
Oh, right. What
very cold, very windy.
I wouldn't like it there at all.
You get. I think the Neptune's winds are the strongest in the solar system. I think.
Oh no, you hate wind as well.
Yeah, like thousands of miles an hour.
Gosh, your hair would be all over the place.
Yeah. Like I say, when we had scientific theory about Uranus not not having its correct orbit. Then we found Neptune. That explained it. Yeah. We also once thought that Mercury's orbit was wrong. And so we made up another planet and called it Vulcan and put it inside the orbit of Mercury, so it was closer to the sun. But then we couldn't actually find it and realised that Vulcan didn't actually exist.
Okay.
But that did start giving birth to things like the general relativity theory, yeah, where Einstein sort of stepped in and said, well, how about my theory on gravity rather than Newton's? And everyone went, oh yeah, no, that works.
Is that E equals MC squared?
Yeah, all of that stuff.
Oh, yeah. It's the only thing anyone ever remembers. I couldn't even actually tell you what energy, mass...
Energy equals mass times the speed of light squared.
And that's what gravity is? Or is that...
No, that's not gravity. That doesn't matter at the moment. We already covered that.
Shows you how much I listen.
Well, yeah, you were listening. Yeah.
Well, hang on. So he had a separate theory of gravity, Einstein. To Newton.
Newton's theory was a little bit simpler.
But he's always been credited for gravity. Isn't
Yeah. He had the original theory of gravity. Einstein just kind of updated it and made it fit.
I'm with you.
But again, he had to do that twice because the first time he did it, he put in a variable that he shouldn't have done, and he had to recalculate. But ever since then, Einstein's theory of relativity and the Big Bang theory, even though Einstein didn't like it, have sat side by side as rock solid. We think this is where the universe has come from and how it works.
Yeah, it's never really been disputed up until recently.
Not really. But like I say, advancements in technology in the last 15 years, or around about 15 years ago, a place called the Sloan Foundation, 2.5 meter telescope in New Mexico, they started seeing some inconsistencies with what they could see out in space that they didn't really know how to explain why it was there. So, sometimes you'll make observations and then make other observations and then another lot of observations, and then it kind of explains itself. But these weren't. So they found something now known as the giant arc, which is a massive string of galaxies, 3 billion light years across.
Jeez. We have telescopes that can see that far.
Probably radio telescopes.
Okay. That's quite large, 3 billion.
That's nothing at the moment, right? So, yeah, we also found something called the huge LQG, which is a group of quasars, which are just kind of like a galaxy on steroids. Like the black hole at the center has turned into this massive neutron star type thing that's just engulfing anything. They're very scary. But yeah, we found a giant group of those, a giant group of quasars that's 4 billion light years across.
Okay.
Very scary.
Yeah.
Right, they found the giant GRB ring, which again is just a giant ring of galaxies that's 5 billion light years across. The Great Wall is literally a string of galaxies 10 billion light years across, and it measures 10% of the observable universe.
That's wild. Because when we're talking galaxies, we're talking several stars, several planets. It's not just one planet, one star. It is a collection. Galaxies are huge in themselves.
Exactly, yeah.
This is how big space is.
Yeah.
I can't wrap my head around how big space is. It just baffles
There's
me.
no point in trying, because you just drive yourself insane trying to just imagine that kind of vast distance.
It is literally one of those things, isn't it, when someone says that I'll try and think of another colour. You can't do it. I can't think of how big and infinite space is. I just can't wrap my head around it.
No.
It's wild.
But that's the thing. the way the universe is kind of created, you got planets and then stars, and then get stars make up galaxies. Galaxies make up clusters, which is what most of these are. Clusters then join up with other clusters to become superclusters,
Yeah.
and then you've got when you zoom out even further, it all looks like a spider web of filaments, all connecting to each other.
Okay.
You know, and we call that the cosmological principle. Is that no matter where you look in space, in what direction, it all pretty much looks the same, and it looks like the bit that we can see.
Okay.
Yeah, because we don't know what the rest of the universe that we can't see looks like. All we can do is hope that it looks like the bit that we can see.
Yeah, yeah.
Because we've learned to try and explain that, but now the universe is starting to do weird things. Like, as I said before, the Hubble constant.
Yes.
Yeah? Now, the Hubble constant, as I said, not James Hubble, was it Edwin Hubble? Was it James Hubble? No, I'm sure it was Edwin Hubble. Okay. Oh, no.
Would you like me to Google it quick?
You could do. Well, like I say, he measured it at 67 kilometers per second per megaparsec. But with, obviously, that's what we call the CMB, the cosmic microwave background Hubble constant. But
You're right.
it is Edwin. Okay. But with more accurate local measurements, what they call it, they found it to be 73 kilometers per second per megaparsec. So it's like when you're trying to measure one thing with two different instruments, they should come up with the same number, but they're not.
Interesting. It should be, but it's not.
Yeah.
Go on.
So I mean, this is the thing. I mean, we can't even decide on exactly what the expansion rate is. How do we know that
It's so hard.
that
Like,
your timeline is correct when you're counting backwards?
How do you even, like, it would all have to be calculations, though, right?
Yeah,
There's no other way of doing
it's not.
it because we're not in that far in space. So it's like,
We are kind of in the middle of a great void in between the filaments, if you like. In terms of like galaxies and clusters and superclusters and all that sort of thing, we're kind of a little island on our own in the middle of a big sea of black in between all those galaxy clusters and that sort of thing.
it's so odd to me that it's like we don't know of there's no actual evidence or hard proof really of other advanced life forms in galaxies and space.
Nothing like scientific, no.
But there has to be. You've got all of those galaxies.
Yeah.
Spreading billions.
Statistically, they've got to be there. But that's the Fermi paradox. That's another question for another time. For a guy whose surname was Fermi, he asked the question, well, surely there's got to be people out there, so where are they? Why can't we see them?
That would suck so hard if we're like just stuck on the only, like, it's almost like Earth
The
is
only
exiled.
rock.
Yeah, like it's exiled. That's how it feels sometimes when you think of how big space is and how there's so many galaxies. But I guess it's all we know, isn't it?
Yeah.
Well, there has to be other theories, if not the
Well,
Big Bang.
This is the thing. Like, yes, we have to theorize the Big Bang. Obviously, clever people with a lot of algebra and mathematics have calculated it. But that doesn't necessarily mean it's right. Like I say, Einstein put a wrong constant into his first theory and had to recalculate. Scientists always are doing this. We can't we've done it with dark matter and dark energy. We can't explain what makes the universe expand, so we just call it dark energy. We can't explain why the expansion of the universe doesn't rip back galaxies apart, and the gravity actually keeps them together. So that's dark matter. And we just create these ideas because we can't actually do the calculations and figure out what the reality is.
Same with spaghettification?
That's when you get too close to a black hole.
Yeah.
That probably
is that
would happen.
theory as well? Oh, they know that would.
That probably would
Oh,
happen.
fair enough. I thought that was just a theory as well.
It is a theory because no one's been that close to a black hole, but like when gravity gets that strong, the distance of like your arm stretching out could be the difference of like 10 tons of weight being pulled on it. You know what I mean?
Right, I'm with you. That's nuts to think about as well.
Yeah. But anyway, right. So what we can do, or what we tried doing, was looking further out in space. Okay, because the basic principle of a telescope is when you look out into space, the light that you're looking at from the stars and galaxies has been travelling for a long time. Yeah?
Yeah. Which is, again, blows my mind.
Well, light takes time to travel, and these things are so far away. Sometimes it takes millions of years, sometimes billions of years. Yeah?
Yeah.
And that's where we could see to, was billions of years back, and we thought, this is the early universe. This is, what we can see, these little tiny little smudges of light that are only faint little, literally fuzzy spots on the camera lens. You can't. There's not really a lot of data you can extrapolate from that. So that's why they did the calculations and figured the Big Bang Theory worked. But then we came up with the James Webb Space Telescope. And this is the reason why...
That's probably where I got James Hubble from.
Could be.
James
Webb. James Webb. Well, this is the reason why I wanted to do this episode, because in recent months and years, it's been out there for a few years now, hasn't it? My YouTube feed gets flooded all the time with, oh, you won't believe what James Webb has discovered. Scientists are scared. And it's like, no, they're not.
Is James Webb the top tier telescope?
Yes.
Right, that's the
That
creme
is
de
the
la creme.
big boy that we've got out there at the moment, yeah.
That's the best there is, the best there was, and the best there ever will be.
Maybe not the best there ever will be, but it's the best we've got right now. Okay, and it's looking deep back in time, because the further you look, obviously the further back in time you're looking, because the light has taken longer to get to you. Do you know what I mean? Mm-hmm. Yeah.
Okay.
So a telescope is kind of like a time machine. You can see back in time. And
craziness.
now James Webb can see right the way back to where they thought the universe started.
No way.
Yeah. And it's finding galaxies there. And it's finding galaxies so far away, so close to the Big Bang. These things are just like maybe 500 million years after the Big Bang. Now, the Big Bang Theory states that it shouldn't have galaxies at that time. They should only have like maybe the first few stars, which would have been supergiant stars that created everything else. These galaxies shouldn't have formed. And not only that, because James Webb is that clever, it can look at it in the infrared spectrum and that sort of thing. It's kind of a radio telescope and an optical telescope all at the same time. It's actually found that in some of these galaxies, bearing in mind this is at the birth of the universe, the very early universe, these galaxies are displaying elements that shouldn't have been created.
Here we go.
Because these elements can only be created by stars dying and then giving birth to more stars that create more heavy elements. So the elements that are found could only have been formed from previous generations of stars, which again take hundreds of millions and billions of years to happen, and there just wasn't time.
So am I right in thinking, if it was the Big Bang that we've all been led to believe, they would pretty much just be looking for hydrogen and nitrogen? Is that right? Is that what you said?
Hydrogen and helium. Yeah.
So that if it was just those two kind of things hanging around, is that kind of right?
Yeah, that would more relate to an early the kind of thing that we'd expect to see in an early galaxy.
But they're finding elements that can only happen after like galaxies are born, basically. Well, that goes into the theory that the universe has always been there, then, surely.
Well, for now, they've just moved the age of the
Science! Okay.
So instead of being 13.8 billion years old now, it's something like 18, or they can't actually decide. That's the problem. I mean, but it does explain kind of Methuselah star that also is apparently older than the universe, and that's a star that's in our galaxy.
Yeah, okay. Well, where that kind of theory is disproven in a way, they've kind of proved the
other one
right.
Well, maybe.
Kind of.
The thing is, like I say, science is one of those things that it's very hard to make something an absolute rule. Everything is a theory. The Big Bang theory is a theory. Even though everybody knows about it, everybody kind of believes in it, and the scientists very much stand on it as a staple of science. And yet, when you look back far enough, you get your nice shiny gold lens telescope.
This is one of those examples where, when you see the videos of people debating and things where it's an extreme religious person that believes that the world was created in 7 days, and then you've got someone who's no, I'm all about logic and science and stuff. The one thing that the religious person will always say is, yeah, but science gets disproved all the time. And they're like, yeah, well, we've got a track record of being correct 90% of the time, but it's still that 10% of where science does change and it evolves.
That is the thing. But science has to change and adapt. So that is the nature of science. We don't do scientific experiments and then just make up our minds that this is the rule. If you do the experiments and you find out that isn't the rule, you have to change the rule, and that's what we might have to do with everything from the Big Bang up.
Yeah. Yeah, so I remember you saying that there's molecules that change when people aren't looking at them and stuff. And I'm like, what is this place? I don't understand how the world works. It's nuts.
The universe is a crazy place, man. It's
I don't understand people that think the sea is space. Do you remember that when it's under the ocean, that's where space really is? I'm like,
what?
No. Have you not heard that theory?
No.
People think that. Oh, I'm probably going to get this completely wrong, but I've genuinely seen some sort of theory where it's along the lines of when you go deeper and deeper into the ocean, you have very similar effects as if you were floating through space. So a lot of people think that space and underwater are potentially the same thing.
I see what you mean, because it's the buoyancy and I guess if you go deeper in the ocean, the currents change, don't they? So you just kind of feel like you're drifting in space. I guess. Yeah, I can see how they make the relation, but realistically, very different. Very different scenarios. Underwater, you're under a lot of pressure, and out in space, you're under negative pressure. The space is trying to pull you apart.
A whole different kind of pressure.
Mm-hmm.
Well, it's scrambled my brains like eggs, because we've always been led to believe that the Big Bang Theory is the main theory.
Yeah.
So it's still the main theory, but they've just changed the timeline, basically.
They don't know what to do with the timeline now. That's the thing. For now, I guess they've just literally stepped it back a few eons and said, the same stuff happened. It just happened a little bit longer ago. But really, at the moment, because of the James Webb Space Telescope, the things that it's seeing, which are defying the rules that we've already created, we have to start changing those rules. And when you change the Big Bang, you are kind of changing everything, aren't you? Yeah,
you are. You are indeed.
So I guess we got to put the Big Bang Theory to the paranormality scale. How much do we believe it now?
If this telescope, you said this telescope's on the spectrum or something, so it can see it can see really out into space. That's some clever stuff.
Yeah.
I mean, if that is getting the evidence of more galaxies,
It's good. The universe is basically going, well, how do you like me now? And the scientists are going, oh, this doesn't compute.
Yeah, I'm not going to lie. It does feel like a bit of a big L for the science community, doesn't it? In a way, it does. Yeah. I don't know. It's tough. It is very, very tough. I like this. This is one of my favourite sciencey ones you've done, actually. I liked your white hole theory before, and your white hole.
I think this actually gives my white hole theory even more credence.
It does. It does indeed. Wow. Wow, wow, wow. For the first time ever, I think I'm going to have to ask you to go first because I'm going backward and forward on the scale. So I think if I get your opinion, it might help me home into how I'm feeling.
I am going to give the Big Bang Theory 4.5 out of 10. Because I think, as far as we know, it's a good theory that's kind of explained everything up to date, but we might need to adapt it. So I can't give it a high score. So with 5 straight down the middle, and four and a half is basically need to do a little bit better.
That's a good way of explaining it. That's a very good way of explaining it. See, I'm torn because we've also been known to, like, if something's legendary, to give it higher scores.
Oh yeah, I guess.
So I'm like, well, the Big Bang Theory is all we know. But if the Webb telescope is as good as we say, then we have to trust the Webb telescope, and we have to move forward and make those adjustments.
It's kind of like we created this brilliant telescope, thinking, yes, this is going to open up the universe to us, and we'll be able to see further than we've been before. Damn, why did we do that? That's just ruined everything.
But I've always had that thought as well of, like, if the Big Bang Theory is the main theory, and the original chemicals and compounds and elements also would have had to come from somewhere.
Yeah.
So I've always kind of had this thought of, like, the universe has always been there, and stars and planets and things over time have always been a result of the universe that is constantly changing and breathing, and it's like I always kind of see the universe as like a living thing in a way.
Well, my other theory was, like, the universe is actually contained within a black hole anyway, that's inside of another universe that's feeding us. Do you remember that one?
Yeah, that's flipped my brain upside down.
So we've got, like, a sliding scale of universes anyway, because we're inside somebody else's universe, and the black holes that are in our universe can also contain other people's universes that we...
You've given me the equivalent of a verbal acid trip there. Basically, that's what's happened. Oh, okay, no messing around. I'm giving it a 3.9.
Oh.
Yeah.
Oh, lower than me. Oh, fair play.
Yeah, it just doesn't... The Big Bang Theory is a nice theory. It has a lot of answers to what we think. I just think... we've got Mother Nature.
Yeah.
Great Grandma Space cannot be contained. There's something about space that we just will never understand. No. And I think for that element, I just don't think the Big Bang Theory adds up fully. I think you're right. I think something needs to change. There needs to be some movement and change of direction, something. But the Big Bang Theory, realistically, only has maybe, like, in my mind at least, 60% of it correct. I don't know. There is that big chunk that just doesn't add up for me. So yeah, I'm going to be at 3.9. Yeah. I think that's fair.
Fair enough. I think that would be a 4.2 average then, wouldn't it?
4.2. Oh, it beat me to it. Yeah. It's just it took the words right out of my mouth. Just about to say that. Yeah. I think 4.2 is fair.
Yeah.
That's definitely an interesting thing. And what I don't like about these episodes when you do these sciencey ones is I now have to go to the gym and I'm going to be on the treadmill. And instead of thinking of, like, you
I
know,
like this song.
yeah, like lovely things of like, oh yeah, tomorrow I'm going to do that, and, having a lovely jolly time. I'm now going to be thinking of like, oh, how did the universe create? How was it created? Oh, could it have been this? Is there any other planets out there?
Why
that we
wasn't
don't
it
know?
just always there?
Yeah, it's just you get my brain thinking now. But it's nice to have my brain thinking rather than turn to mush for a change with
Yeah.
sciencey ones.
Yeah.
So
I didn't turn you to mush this time.
no, there was that one episode. I can't think what it was, but it's like when I watched it back, you can literally see my face like, oh, I don't want to be here. I don't know what's happening. It's too much.
I think I did. I think that was the
Yeah.
general relativity one, wasn't it?
Probably.
That actually explained how it worked.
That would explain why I couldn't understand E equals MC squared still to this day. It's too much for my brain to handle. That was a good episode. I liked that. Very science. If other people have theories about how they think the universe was created, let us know.
Yeah, right in. I'm all ears.
Yeah. If your last name is Universe and you have a great grandma Universe, let us know.
Paranormality.uk@gmail.com. Always been the same. And yeah, I guess it's a bit of a shorter one this week, but
That's all right.
you don't want my sciencey ones to be too long anyway, it is.
You've got to give people time to catch up and recover.
Yeah.
And it's almost like a marathon with these ones. So I think we need to put a disclaimer in the description at the start of like sciencey one, prepare your brain. So then people can have a banana and they can have some oats and a cup of tea and get prepared for it.
Well, at least it was a good one. It was a fairly straightforward
I liked
sciencey
it.
one.
Thoroughly enjoyed it, to be fair. It's not quite as good as your white holes. I did like your white hole one. That real tickled my teats. This one was just a little more of an itch, like my teats are dangling and you've just itched them a little bit. And I've gone, oh, get away, pirate. Stop.
No milk today.
No, stop itching my teats. Whereas your white hole one was full on like tickling my teats where it got my interest, That analogy sounds so wrong out of context to people that don't listen to the pod.
You have mentioned Pirate's White Hole plenty of times now.
Yeah, we're talking about you. Pirate's white hole and tickling my teats. It's the great combination.
I'm going to go.
Yeah.
Right. Until next time, I've been Pirate.
I'm Josh.
This has been Paranormality UK. Ta-ta.
Ta-ta!